Hello, we're going to compare the C2 notes on a Steinway, I think it's a Model B, and a Knabe, which is a 1927 7-foot 8-inch Grand. First we'll hear the Steinway. Now comes the Knabe. That was the Knabe again. That was the Steinway. Okay, these are the time domain traces of the two notes. Notice that the Steinway amplitude, watching the little cursor there, kind of drops off relatively monotonically. The Knabe drops off a little bit to the 1 second point, kind of holds steady for and gets a little bit stronger for about 2 seconds, and then at 4 seconds it appears to be attenuating, and then it picks up again for about 2 seconds. That is, there appears to be an envelope wave having a period of about 2 seconds. Now let's look at the spectra. Hold on while it does all the computations. Okay, here's the line spectra, power versus frequency. The frequency resolution is about 0.15 hertz. Okay, the fundamental for the C2 note is 65.4 hertz, which is right here and right here. And notice that on both pianos, the contribution at the fundamental is relatively small. Both have strong second harmonics here at 131 hertz, or near 131 hertz. The Steinway gives the most power at that harmonic. The third harmonic on the Knabe is its strongest. That's at 196 hertz. The third harmonic on the Steinway is a little bit weaker. The interesting thing here is that the peaks on the Knabe are sometimes doublets. For example, take a look at the second harmonic here at 131 hertz. Okay, it's got two peaks, and actually it's a little bit south of 131 hertz also. There's another one, 196 hertz. Let's take a look at that one. 130. I think it's this one right here. Yeah, there it is. See, it's a doublet too, for some reason. Also, the 13th, the 14th, and the 15th are doublets. For example, right out here. See, those two, those two are doublets. There are far fewer doublets on the Steinway spectrum. There is one down here around the 11th harmonic. I think this is it here. Yeah, this is well, actually, this is another one. This is not the 11th harmonic. But here's a doublet on the Steinway. Not sure what all that means. So you can tell there's a difference in the spectrum, the spectra of these two. Now let's take a look at the cumulative spectrum to see a little bit better where the contributions are coming from. Okay, here's the Knabe's cumulative spectrum. This is the cumulative power plotted versus frequency. And you can see that there's absolute, well, I should say absolute, but almost nothing going on here at the fundamental. No contribution at all. Take a closer look on the Knabe. You can see that at 65 hertz. There's a little hiccup, a little bit of contribution, less than probably a tenth of a percent. Down here on the Steinway, we have a similar situation. There's again a little burp, a little contribution there at 60, a little bit above 65 hertz. The Steinway has almost 50% of its power from the second harmonic. On the other hand, the Knabe only contributes 35% of the power at the second harmonic, but it contributes 25% right in through here at the third harmonic. There's also some contribution clear out here at the 13th harmonic. Let's take a look at that, which is supposed to be near 185 hertz, 850 hertz. Notice the little flat spot right there? That's a consequence of the doublet. The only other major contribution in the Steinway spectrum is in the 6th harmonic right in here at about 392 hertz. Let's see, yeah, there it is. So there's maybe a 12% increase, 12% contribution at that harmonic. So they're significantly different in the way the power is distributed over the frequency.